So a little bit of introduction, since many of you may not know me, Tim Titus, Chief Technical Officer, also founder of PathSolutions. My background is I've been a network engineer for 3 decades. There's a little bit of gray hair there that should help prove that. Started back in the days of coax, ArcNet, DIP switches, Novell NetWare. So I've been fighting network problems for really most of my entire career. One of the things that frustrated me, and I'm certain frustrates a lot of folks out there, is troubleshooting. The problem with troubleshooting is that you have to say, gee, go set your monitoring software to go collect certain pieces of information. And then you realize you don't have enough information and you have to go collect more information. And you use a variety of different methods to collect the information. Then you have to put the pieces together. Typically, this is a manual process. And if you don't have all the right pieces, you're not going to come up with the right conclusions. So this means that if a user has a problem, that means that you say, gee, I couldn't find it. Maybe the next time this happens, we'll get a little closer. That frustrated me. And I figured there needs to be automation for troubleshooting. So I looked around and realized most of the monitoring software that's out there doesn't really do automation of troubleshooting. You can build your own automation if you want to. But if you wanted something out of the box that you could deploy and have it analyze your entire infrastructure and tell you everything that your network equipment knows, at that point, you could start being proactive. And so that was really our dream. So I think many folks will end up seeing a network that ends up looking like this. You set up your monitoring server, you set up a database, you set up a couple of remote collectors to deal with scalability issues. Then you set it to monitor your switches, routers, gateways, and firewalls. And this tends to be a bit of a manual exercise. If you miss anything, well, then oops. In addition, you want more information in a few select areas on your network. So you go out and you manually configure monitoring of your internet connection, maybe your WAN connections, maybe some trunk ports. So you go out and do this. And at this point, you say, I've spent months configuring this, and this is the visibility I have. And maybe you're also run out of licenses because this is as far as you've been able to purchase. At this point, when a user has a problem, they're going to say, hey, I had a slowdown. I had a database drop a connection on me. I had a call quality issue or a video conferencing issue. Okay, you check your monitoring software and your monitoring software says everything's good. What that is it's a disconnect between the reality that's actually occurring on your network and what your monitoring software is aware of. So that means you're left having to stuck log into switches, log into routers, check interfaces, check error counters, check configuration, looking for that needle in a haystack as to what caused the user's problem. Sadly, if the problem isn't happening when you're looking, you're not likely to actually find it. So this just leads to a frustrated user, you're frustrated, your management's frustrated, and the problem doesn't go resolved for either days or weeks or even months before people can find it. So I figured the automation of troubleshooting really needed to come into play. And again, the other monitoring software, they're manual. You can set up monitoring of whatever you want, but that takes effort, knowledge, and time. So here's what we decided to do. In automating the troubleshooting, we have a solution that deploys on a single virtual machine in your environment. It's going to go out and automatically find every switch, router, gateway, and firewall and monitor all of the devices as well as every interface on every device. If you think about it, you're held to be responsible by your management, by your user community, to be responsible for the entire network. We're going to give you visibility that matches your responsibility. Secondly, we're going to go deep. No matter what make or model or manufacturer this equipment is, we're going out to automatically collect the performance, the configuration, 19 different error counters, all the QoS, CDP, LLDP, PoE, all of this information automatically collected. And then we take this information back and put it through a heuristics engine. The heuristics engine analyzes and comes up with plain English diagnostics, whether it's a bad cable, it's a QoS misconfiguration, duplex mismatch, microburst link flood. We're going to be able to say, here's what's going on in your network so that within the hour of deployment that you take, we're going to tell you, here's everything that's broken. Now, if you knew everything your network equipment knew within the first hour of deployment, you'd say, let's start proactively fixing these things. And instead of running a network that's full of mystery and unknown, you're able to run a network that's perfectly operating because you know everything your network equipment knows. Now, to round this out, we have everything needed to run a perfectly healthy network, including diagramming, path mapping, port mapping, server monitoring, service monitoring, inventory, NetFlow, IPAM, and also configuration automation for deployment of configurations and backups of configurations. So everything needed to run a perfectly healthy network. So that's our core offering. We don't chintz on things. We include all of this in the core offering so that everything needed is included. Now, we do have some optional modules. One optional module is our telecom module. What that includes is the ability to do call path mapping. So if somebody says they had a poor quality UC call or VoIP call, we can path map and show every link, switch, and router used to connect any two endpoints and show here's what happened along that path. So in that sense, you could say, gee, we're a little like NetBrain, except we're like NetBrain with the root cause answer of what happened along the path at any point in time. That way we can tell you your call that happened around 2:30, it was bad because we had a QoS misconfiguration, and a few minutes later, we had a bad station cord causing packet loss. So you get the root cause answer with one report and one tool. In addition, we have APM. So we have a call simulator that you can use to simulate synthetic voice traffic across the LAN, across the WAN, or all the way end to end to determine quickly where do we have latency, jitter, packet loss, out of order packets, or loss of DSCP tag. The telecom module also includes full visibility into Cisco QoS queues. We'll do SIP trunk monitoring and troubleshooting. We can locate your phones and trigger alerts if phones move. We do MOS score monitoring, so everything needed for a perfectly healthy voice environment. Next is those work at home users. So if we go through a sample scenario, you have a CFO working from home. They have a poor quality Zoom team meeting. If you scope the problem out, you recognize there's the internet part, there's the Zoom team cloud server component, there's your headquarters component, and then there's the user's home office. In their home office, they have a $29 firewall, some completely unknown brand of access point, and they have their laptop. Now, in this environment, you can have a bevy of errors. You can have weak wireless signal strength, wireless channel contention in the neighborhood, firewall issues, ISP issues, split tunneling issues. So if you try and help this user out and say, hey, let me see if I can solve your problem, the first thing you try and do is say, let's schedule a meeting where I can work with you on this. And the user and your schedule only seems to coordinate maybe 2 days from now. At 2 days, they try and get into the meeting and their packet loss is too high or the latency is too high. They can't get into the meeting. Even if they do get into the meeting and they pass control over to you, the only tools available to you are ping and traceroute. Not a whole lot of usefulness. So here's how we decided to come at the problem. What we do is you send the user a single agent and say, here, non-technical user, run this. They run that. It's going to perform a batch set of tests against all of these different elements, bring that information back according to the user's perspective of the network. So you get their take on what's going on in the network. That information then gets put together and sent back to the TotalView server. And then you, as the engineer, get an email notification saying the lab results are in, the doctor can now review what's going on. At that point, you look in and say, okay, looks like your CPU and memory, that's good, so your laptop's healthy. Looks like your wireless signal strength is low. I'm going to suggest you move to a different location or plug in. Also, in your neighborhood, if you are going to use wireless, everyone's using wireless channel 3. If you change that, you're going to have a better time. Also, your firewall's adding a bunch of latency, your ISP is having some really bad slowdowns. So with all of this information, super technical information, automatically collected by the non-technical user, presented to you so that you can end up looking through and saying, here's 5 things you can do to improve your work at home environment. That just means that you're not spending hours trying to solve a problem because you don't have the right tools available. You have all the information in front of you so that you get the problem solved quickly. Now, you can also have users do their own wireless signal strength mapping exercise of their house. So here's a screenshot example, and you can see the RSSI signal strength on the left side. It was kind of yellow. I started that test in my kitchen. As I picked up my laptop, I would start walking around, and second by second, it would update to show what the wireless signal strength actually is. That way, when I walked into the living room, it was nice bright green. As I walked out the back door into my yard, it quickly dropped to yellow, red, and then black as the signal strength just completely dropped away. So what this means is you're going to have all of the ability to help those users who are working at home, help them solve problems because you have the information in front of you. So with this, we figure we have all of the information on your wired network, on your data center network, on your work at home users, on VoIP and UC, that you can root cause troubleshoot all of these problems with ease. If you guys have questions, I'd be willing to take those questions.
Tim, I've got one around the automated discovery of the infrastructure. How was that handled in PathSolutions? Am I setting up subnets to constantly scan? Am I setting up seed routers? What does that look like?
So we have, currently it's based upon subnets to scan to find devices. We are adding seed router in our very next release, so that's coming very soon. But it's effectively is, since we know everything about the existing devices that are there, we're going to say, gee, we're monitoring a Cisco switch, for example. We know what's plugged into every port on that switch. If we see CDP or LLDP information for some new device that's plugged in, we can go out and start talking to it to say, okay, what are these new devices? Do they respond to management? Can we get information off of them?
So what kind of devices are you supporting for those discoveries?
So it's really anything that responds to SNMP, and it's SNMP v1, v2c, v3, and Cisco's high encryption v3 as well.
If you deploy a new network device, does it automatically discover the new device, or do you have to tell it to like initiate another scan?
So you can tell it to initiate a scan to immediately have that happen, or you can have automated scans saying, generally people do once a day, because their network is not changing that rapidly that they figure once a day they'll have a scan to say, okay, we found this new device, looks like it's a printer. We found this new device, responds to public, it's sitting under somebody's desk, and it's some old Netgear switch that somebody said, gee, that's not part of the infrastructure, we don't want it here, but we'll still discover that sort of stuff as well. So the trick is that the knowledge is out there. Your network equipment has all of this information, and I think what needs to come to an end is the day and age where network engineers are scraping devices, hunting around for clues to try and solve problems. Those need to be automatically found, automatically collected, bubbled up to say, hey, you have a trunk port problem over here. You have a microburst link flood. With the answers given to you in plain English, it means you can start being proactive about solving these problems, because the finding and interrogation of the stuff is completely automated.